Hello fellow problem solvers. So today we're going to be doing what is easily one of my top 10 geometries of all time that I saw. And it's one of my favorite problems from the All Russian 2014 Math Olympiad from grade 10, day 1, problem 4 out of 4. And I suggest you try this beautiful problem out for a minimum of 45 minutes, ideally an hour and a half, 2.5 hours, not more than 4.5. If you'd like to go along with us, give this a go for the next 10 to 15 minutes. Draw the diagram and put your first ideas out on paper. And now, without further ado, let us begin. So, what do we have here? We have a geometry, okay? Okay, B seems to go on top here. And we're going to have these M and N, okay, AM, C, N, great. We intersected with AC. Decently standard-ish, nothing too big. And then let, okay, the in-center and the X-center, okay, that's P, that's Q. Midpoint of, oh, look at that. This is why I love the problem, because of this whole thing. Like, we're connecting the midpoint of an arc of ABC with this in circle and X circle. Like, what are we doing? How do we even begin? And of course, there are two ways to go about this: forwards or backwards. Let's go forwards. And here's the thing with geometry problems which are of this size. You know, there's a couple of, we have ABC, MN, and then we have K, and then we have points R and P, R and Q, and then we have P as well. We have 9 points here. So let's take it point by point and let's figure some stuff out for some of the points and then build up from there. So the first order of business is, what do we have from AM to CN? That's number one. And secondly, also, another thing to think about is R is sort of added as an afterthought, right? It's like, oh, you have these intersections, like you have MN, like you need ABC, okay? You need ABC for everything, but then M and N, okay, when you pick M, N is defined, like there's only one such N. And then when you intersect, like K depends on M and N. And what's it called? Both Q and P depend on this M and N. They depend on K, which depend on M and N. And then at the end, it's R, which has nothing to do with M or N, or so it seems. So those are like the two things to keep in mind. R is added as an afterthought, like, oh, and here's an R. And the other thing is that everything depends on these points. So let's take it building block by building block. So we're going to first draw a diagram. Okay, we're going to draw some circles. It's not going to be the best diagram, but it's just the first one that we're going to work with. Okay, AB is greater than BC. Okay, how do I want to draw this? I usually draw triangles like this here. This is usually the side in which I'm comfortable drawing triangles. So that's why I'll draw it here. AB is greater than BC. AC. Okay, now I pick my M and N. And it seems if I pick M, that's closer to here. And then I have to pick N is going to be above it. And this is, MN is going to intersect CA over here. Okay, but let's not get ahead of ourselves. What do we know about points M and N? What can we get from this? And another question to ask is, okay, the R that's added at the end as an afterthought, can we connect it to M and N? Because we're going to need to connect it to P and Q somehow, but M and K are the things that define the points P and Q. So can we first see if we can connect it to things which seem more closer to it in some way, shape, or form? So now let's look at that. Let's look at R being here. And I invite you here to pause for the next 5 to 15 minutes and try to push the problem further. And here's the next step. So we have, for R, it's the midpoint of the arc. So RC is equal to RA. Okay. And we have this angle over here is equal to this one. RCB is RAB. And now my question is, did you notice anything? And it's a side, angle, side, side, angle, side, similarity, that's actually congruency that we have here. So What does this give us? It gives us that. So let me just write this down in terms of we're going to have RC is equal to RA. We're going to have CN is equal to AM. And the angle RCN is equal to the angle RAM. Okay? Now these three facts combined together give us that the triangle RMA is congruent to the triangle RNC. Okay? So now from this congruency, we have more angles that we didn't have before. We have the angle RNC is RMA, which also incidentally gives us that R, B, and M are also concyclic. That's what that gives us. And it gives us that Rn is the same as Rm. Okay, now here, this is just our first go, our first diagram. Can we figure anything else out? Yeah, can we figure out anything else from M and N given this? Mind you, this also gives us like some sense of, not a huge sense of, but some little sense of, this angle MKMA is equal to this angle BMN, which is equal to the angle. So BMN is equal to BRN. And hey, who knows? And yeah, BRN, like not super duper useful now, could be used in the future. Like we might also want to think, okay, we have this angle is alpha, call this angle X. This is alpha minus X. And then I have this angle over here is X, but the whole angle is alpha, so this one is alpha minus X. Oh, would you look at that? What do we have now? Pause for 5 to 10 minutes. And the answer is, well, it's been a lot, I haven't prepared for this problem, it's been a long time since I've done it. But we have that so RNC, K, seems to be concyclic, because this is alpha minus X and this one is alpha minus X. So, because of that, we have more concyclic points. And mind you, I haven't even begun to add in R and, Q and P. Because it's the in-center and the X-center. How do I connect that to R is still beyond me. So that is why I'm not even rushing. I'm like, I'll add that at some point. Right now, I'm chilling. I'm cool with what I have. Let me just try to push it more, push it further, connect all these points together. And if you think about it, like pause for 10 minutes and think, if you know that R, N, C, K are concyclic, what else should you be able to know? Okay? And the answer to that is, well, here's the thing. If R and C, K are concyclic, like A and C correspond to M and N. K is meant to be sort of symmetric with respect to like A and C. Like it's in the middle. It's like B. Like with everything that we've defined so far, so is R. So if we have something holding for R and CK, the same thing you would expect it to hold for RMAK. And does it? Well, from this similarity, or actually congruency, you also have this angle over here is equal to the angle MRA needs to equal to NRC, which is also alpha minus X. And we have alpha minus X, again, now RMAK are also concyclic. Now this gives us a lot of concyclic points that we're going to have to deal with in some way, shape, or form. And here's where I invite you to pause for the next 10 to 20 minutes, actually even half an hour, and try to push the problem further. Would you like to figure anything else out about K? Like I found a lot of stuff out about K just by by how we've defined everything and added everything, R is also like pretty interesting. Like we've connected R and K in some way, shape, or form. We have 1, 2, 3, 4 circles, right? One that was the initial one, ABC, but we've uncovered 3 more circles. That's more information. We've uncovered that R is also in the midpoint of NBM, that arc. So we have a lot of stuff going for us, a lot of good stuff. And now here's where I invite you to pause and see, do you want to find more good stuff? Or do you want to add the points P and Q and then play around with that good stuff? And let me clear up the board, and I'll draw a nicer diagram, and we'll get to our next step. And what we get when we draw a much nicer diagram is the following. Big picture. Now, I've also done the liberty of calculating some angles, calling this angle over here X, the alpha, beta, gamma, the usual. And I introduce points P and Q. Like, I don't see anything else we can add to points M and K. We've done a lot. I still don't know how to connect R with K. We have these angles, but let's see, is there anything interesting going on now? How are we going to connect R with Q and R with P? Like, that is a question. And what I'm getting at here is, okay, if I call this X, this is X half, this is alpha minus X over 2. So this here is alpha half. The angle MPQ is going to be alpha half. And now what is this angle? Well, we have a 90 minus beta plus X, so a total of 90 and then beta plus X, which gives us a total of 90, let's write it, 90 plus beta half plus X over 2. And I have alpha half minus X over 2. So the X's over 2 cancel out. I need to get gamma half over here. Okay. Gamma half there. And it's also, it's half of this angle over here. So this is beta plus X over 2. Now, still, any signs of connecting these dots? I don't see it just yet. Also, this here is gamma. Because this whole angle over here, RA. Actually, no, it's not gamma. It's equal to alpha half plus gamma half over 2. Yeah, alpha half plus gamma half. And so, like, this one is also alpha half plus gamma half. This whole angle is alpha half plus gamma half. So this one is alpha half plus gamma half minus X. And now the question is, okay, RP, RQ, do you see a way to connect the two? Or maybe another question would be, is there anything that would seem to you to be a bit a natural connection, something that stands out from the diagram? Now you can pause for 5-10 minutes, think about that. Or also, we can continue on and say, okay, wait a second. Can I use, I need to somehow, so the P and Q are symmetrically somewhat defined. I need to show that in a sense. Not really, but just in some sense. I had this is beta plus X over 2. Maybe that's the thing that, I don't know, that could be the same for all, something that's not identical, something that's, how do I say this, maybe invariant with respect to A and C, but it's something that's symmetric with respect to A and C. And the corresponding angle here is this one, and this one is what? Alpha half minus X, gamma half plus beta half over 2, gamma half plus beta half, and then we have 90 minus X over 2 is APQ. Now we're not quite there yet. Like the sum of these two angles is 90 plus beta over 2. It doesn't quite seem like we're there yet, but it seems like we're getting closer and closer and closer to a resolution to this problem. And then maybe the next question I would ask you is, Okay, these P and Q, they're both on this angle bisector. Is there something else that might be here that I can use to further establish a connection between R and Q, R and P? Because frankly, like one thing that you might come up is that R and Q and R and P are congruent. Like it seems like there's a lot of things moving around here, like the NC goes to MA, like there's some sort of reflection thing happening. But the Q and P are sort of on opposite sides, but still they look similar-ish. And the angle I have here is like what? It's 90 plus beta half plus x half, and then I have alpha half plus gamma half over here, like with this angle. And that gives me a 180 plus x over 2 here. So the angle R and Q is going to be 180 minus x over 2. And then over here, the R and P, well, I have what? What do I have? I have that RMP here. RMK is what I need. And so RMP, this is alpha half plus gamma half. So this angle over here is going to be equal to 90 plus beta half. Right, because I need alpha half plus gamma half, and I need 90 plus beta half, so R and P doesn't quite add up. So R and P is equal to then 90 plus beta half plus x over 2. But see, like this is the general, how we solve problems. Like we have, it looks like these two are congruent, but then maybe not. Doesn't really look like x can be pretty much anything. I can move m and n around. Doesn't really, like maybe the sum of these two angles can give me something like 270 plus beta half. Perhaps there's something there. Maybe, maybe not. And this is the part of the problem that I find exquisite, beautiful. And that is to say, okay, we cannot connect these P and Q directly, it seems. Right now, we don't have a direct connection. So, can we connect them in some other way, shape, or form? That was very vague, I realize. Also take into account that R and CK are on the same circle. And is there something we can use with that fact in mind? And the idea is, okay, let me take the midpoint of this arc over here, of the arc NC. And let's call this midpoint Y. And so now, what do we have for Y? We have by a lemma, that's Yn is Yc is Yq. This is the in-circle, X-circle lemma. Yn, Yq. And with this, we also have the angles. We have this angle here is meant to be disgusting. Alpha, like it's not disgusting, it's just my picture is becoming very bad. Alpha minus x over 2. And given this one was 190 plus minus beta half minus x. In other words, alpha half plus gamma half minus x over 2. This makes this other angle here equal to gamma over 2. The angle Y and Q. And also, like I can connect, I know that Ry, given this is the midpoint of this arc, I know this is the angle bisector, that this is alpha minus x over 2, alpha minus x over 2. So now, and then when I do the similar thing here with x, and I have my angles that I calculate, like here I'm also going to get, so I have mx is xa is xp. I'm going to get this angle over here again, alpha minus x over 2 is equal to this one. So this here is alpha half plus x over 2. And similarly, we have that we have a horrible diagram, but try to connect it like this, that this is also Rx is here the angle bisector. Alpha minus x over 2 and alpha minus x over 2. And why do I do this? Well, I know the size of XA is equal to what? I invite you here to, with this idea, try to push the problem further for the next 10 to 15 minutes. And here's the next step. What we have is, once we clear the diagram, we have this. So, think about it. We have Rn, Rm, Rc, Ra. This is the angle bisector where it intersects the circle around R and C and K. And the same with X. So immediately, we get that N, M are corresponding, C, A are corresponding, Y and X are immediately corresponding points, which means we'll get from sides, now we get what's called, we have this angle, R and Y is equal to R and C plus Y and C, which is equal to RMA plus XMA, because XMA and Y and C are identical angles. They're both equal to NKC over 2. And with that, we get that NY is equal to MX is equal to XA is now equal to YC is equal to our other 2 points, our dear old Q over here, and our dear old P that's going to be somewhere around, I want to say here, is equal to that. And now think about it. And also we know that Ry is going to equal to Rx by side angle side. Yeah, so like we have the side, we have this side, this angle, and now we have this side. So we're going to have that Ry is, I don't even know what to use anymore. Ry is the same as Yx, is Rx. And with that in mind, if we had the problem condition was true, that Rp was equal to Rq, then the triangles RYQ and RXP would be congruent. In other words, we'd have these angles are equal. And this is why I love the problem. Like, this is the end of the problem. We just need to find, show that given everything we've said thus far, that RXK and RYQ are identical. What is that equivalent to? Well, that is equivalent to RXY equal to RYX, which is true because RY is equal to RX, and so we're done. This is an absolute monster of a problem in a good way. Like a nice fluffy monster from Monsters Inc. So it's a beautiful problem. It has, like, this part where you add these points, the midpoints of the arcs, are what make the problem. The reasons why you add them is because you want to find, you can't connect RQ directly. You can try with N, it doesn't seem to end up working. Like, you don't have congruence. You don't have that NQ is equal to MP. That's your problem. So, and you try out that. You see it doesn't work. So you're looking for another point, another 2 corresponding points, which can connect them together more. And because you know that, like, you need to have in the back of your mind the in-center, x-center lemma, that this, if I take the midpoint of the arc, MA here, that I'll get this is equal this is equal this. And then you combine that with the fact that you have these 2 similarities. This is also called, from what I know, a spiral similarity that sends that R and C, that sends NC to MA, with R being the center of the spiral similarity. And so when you have corresponding things there, and here it's spiral congruency. So when you have corresponding things there, like N corresponds to M, C to A, like Y and X makes sense to add them in, because you have that they are immediately corresponding to one another, and they somehow are actually closely related with both Q and P. So that's the reason why you add them here. Now this finishes up our problem. I think it's beautiful. This is one of my favorite geometry problems of all time, top 10 without a doubt, and absolute beauty. And as always, just like yourself, as always, thanks for problem solving.